Hello Bobcats. So for today we're going to talk about expanded octets. And the two expanded ones that we're going to talk about is phosphorus and sulfur. And remember earlier we said that phosphorus can either have 8 electrons or expand to 10 electrons. If we looked at the electron dot structure of the valence electrons for phosphorus, there's 5 valence electrons. We have a pair and then 1, 2, 3. So you can see here that there is space for a shared electron here, a shared electron here, and a shared electron here. So that would be 1, 2, 3 bonds. So if you do not expand, then the phosphorus, to get its octet or 8 electrons, will have 3 bonds and 1 lone pair. But there are many times where phosphorus will also expand to have 10 electrons with 5 bonds. So let's look how that happens. First, let's discuss the non-expanded using our electron orbital diagram. So not expanded. So let's look at the not expanded phosphorus. And if I take phosphorus and I write it, remember we're just looking at the valence electrons, so that's the 3s orbital, and then we have 1, 2, 3. 3 p orbitals. So there's the 3 p orbitals. And we had 5 valence electrons. We have 1, 2, 3, 4, 5. So you'll notice that these orbitals have space for electrons to be shared or bonds to occur. But this does not have that. Now remember, we are in the third energy level. And in the third energy level, the sublevels that are available are S, P, and D. Now D is not being used on the third energy level yet, but it is available. It is there to be used. It's just not being used at that time. So let's see how phosphorus expands. So let's take the expanded look at phosphorus, where we're doing an octet of 10, or 10 electrons around it. So again, we have phosphorus, but now I'm going to look at, we have S, and then we have 3 p orbitals, and then we have 1, 2, 3, 4, 5 d. So this is the 3s, 3 p, and 3 d. Now what it does when it expands is it takes this electron and puts it into a d orbital. So we have 1, 2, 3, 4, 5 electrons. So there's 5 spaces, empty spaces for shared electrons. We can have 1, 2, 3, 4, 5 bonds, or a total of 10 electrons around the phosphorus. But remember, the off-ball principle says that you have to fill lower energy levels before you can go to higher ones. So the atom really can't accept this. So what it does is it goes through hybridization. So it takes these orbitals and hybridizes them so that they're combined, and it makes them all the same energy level, 1, 2, 3, 4, 5. So now they're all the same energy. And then we still had the 4 empty d orbitals up here. And so those 5 electrons go here, and these are all now equal. They're not s or p or d orbitals. They're a hybridized s p3, because we're using 3 p's d. It's an sp3d hybridized orbital. And in a couple of lectures I will show what that hybridized orbital looks like. It's not a sphere and dumbbells and a clover like. It's something different, okay? All equal in energy. And so we call this a hybridized orbitals. So phosphorus hybridizes or creates these equal orbitals so that it can have 5 bonds now. And it does that because the third energy level has available 3d orbitals. So if you think about it, right above sulfur is oxygen. Oxygen's on the second energy level, so it only has s and p orbitals available. There are no empty d orbitals available on the second energy level, so oxygen cannot hybridize. Oh, I'm sorry, or nitrogen. Nitrogen's above phosphorus. Nitrogen cannot hybridize because there are no available d orbitals on the second energy level. So now let's look at the other hybridized or expanded octet, and that would be sulfur. So I'm going to take a different color for sulfur. And sulfur, remember, sulfur has 6 valence electrons, so it's going to be 1, 2, 3, 4, 5, 6. So we have 2 lone pairs and then 2 electrons that are available to be shared and create a bond. And so when it's getting the octet or 8 electrons, sulfur will have 2 bonds normally with 2 lone pairs. And when it expands, it could expand to 12 electrons, which means it's going to have 6 bonds around it. And that's the expanded octet or expanded sulfur. Okay, so how does it happen for sulfur? Let's look at this again. The not expanded. So when it's not expanded, sulfur has an orbital diagram of 3s and 1, 2, 3 p's. So that's the 3s and 3p. That's 1, 2, 3, 4, 5, 6 valence electrons. So you'll notice you can make 2 bonds here, and then you have 2 lone pairs where they can't bond. But sulfur will also expand just like phosphorus did, in which we'll have, and I'm going to start out showing the 3 different orbitals, sublevels. We have 3s, 3p, and then the 3d. Now remember, the d's are available, they're just not being used yet. So 3s, 3p, and 3d. And so these 2 electrons that are paired up will actually go into orbitals here. So we'll end up with 1, 2, 3, 4, 5, 6. So now it can make 6 bonds. But remember, Aufbau states that you have to fill lower energy levels before you can go to a higher one. And so the atom has to hybridize these orbitals right here. It has to hybridize those orbitals and make them all on the same energy. So 1, 2, 3, 4, 5, 6. And then there's the extra 3d orbitals up higher in level, and these are now able to make 6 bonds, which will then have 12 electrons around the sulfur, and that's why it can expand to 12. And these hybridized are an s because we're using 1 s orbital, p3 because we're using 3 p's, and then d2 because we're using 2 d's. So that's an sp3 dehybridized orbital, all of the same energy, so that it can create 6 bonds. And again, it only happens because it's on the 3rd energy level and there are available empty 3d orbitals. And so that is how the expanded octets occur, where you get an extra, you can go up to 10 electrons for phosphorus, would be 5 bonds, and 12 electrons for sulfur, which would have 6 bonds. And that is expanded octets. Thank you.